Good day, young engineers, and now we are going to tackle about single-phase and special-purpose motors.
So for the first problem in single-phase and special-purpose motor, states that find the induced torque in the motor if it is operating at 6% slip and its terminal voltage is 220 volts. Given the following main winding impedances, R1 for 1.4 ohms, R2 1.5 ohms, X1 1.9, X2 1.9, and XM for 100 ohms. To calculate the induced torque, we have this given equation. So let's proceed to the solution. For the solution, we must first get the current in order to calculate our air gap. So this equals to terminal voltage given R1 plus J X1 plus 0.5 and 0.5 ZF. Since we don't have ZB and ZF yet, solve the following unknown. ZF is equals to R2 over S plus JX squared X2 multiplied by XM over R2 over S plus JX2 plus JXM. So 1.5 R2 over 0.06 slip plus J 1.9 in X2 plus J of 100 over 1.5 over 0.06 plus J 1.9 plus J 100, which is equal to 22.71 plus J 7.44 ohms. So next, we have to find the ZB, where ZB is equals to R2 over 2 minus S plus JX2 plus XM over R2 2 minus S plus JX2 plus JXM. Substitute 1.5 2 minus 0.06 plus 1.9 plus J 100 over 1.5 2 minus 0.06 plus J 1.9 plus J 100, which is equal to 0.744 plus J 1.87 ohms. So therefore, we can solve for our I1 because we already have ZF and ZB. So let's substitute ZB and ZF in our equation I1. Therefore, I1 is equals to terminal voltage over 1.4 plus J 1.9 plus 0.5 times 22.71 plus J 7.44 plus 0.5 times 0.744 plus J 1.87. So it is equals to 14.99 angle negative 26.535 ampere, or approximately equals to 15 angle 26.535 negative ampere. From this, we can solve the following power. I1 squared times 0.5 RF, or equals to 15 squared times 0.5 RF, which is 22.71, then equals to 255 4.9 watts. So next, air gap is equals to RP 15 squared times 0.5 of 0.744, so is equal to 83.7 watts. So since torque induced is equals to over, we can solve first for air gap, where air gap is 2 of minus then 2504.9 minus 83.7, then it is equal to 2471.2 watts. So torque induced is therefore equals to 2471.2 over the 3000 revolution per minute times 2 rad over R times 1 minute over 60 seconds. So cancel, which is then torque induced is equals to 7.866 Newton meter. A three-phase permanent magnet stepper motor required for one particular application must be capable of controlling the position of a shaft in steps of 5 degrees, and it must be capable of running the speeds of up to 250 revolutions per minute. We have to find the following: calculate how many poles and at what rate must control pulses be received in the motor's control unit if it is to be driven at 250 revolutions per minute. Given the following values: mechanical angle of 5 degrees and electrical angle of 60 degrees, and the speed of 250 revolution per minute. We can find the number of poles. It is equals to 2 times the electrical angle over the mechanical angle, or 2 times 60 degrees over 5 degrees is equals to 24 poles. And B is to find the number of pulses be received in the motor's control unit if it is to be driven at 250 revolution per minute. So N pulses is equals to N times number of poles times the speed, or 3 phase times the 24 poles and 250 revolution per minute, where 250 revolution per minute being converted at revolution per second. So simply 250 revolution per minute times 1 minute over 60 seconds. Minute will be cancelled. Then the answer is 300 pulses per second. So therefore, 300 pulses per second is being received in the motor's control unit if it is to be driven at 250 revolution per minute.